trigs. Okay, so for trigs, there's these subtopics: radians, arcs, and sectors, graphs, and trig functions. They're trig identities, solving trig equations. Yeah, but today we're doing these two. The aim is to finish these two, right? Along with all the past papers. Of course, you need to know your syllabus objectives, so you know exactly what you need to know for your exam. So they require you to define a radian. Don't worry, it's not going to come in the exam. They're not going to ask you to write the definition of radian on your exam. That's just to help your understanding, right? You can't do a whole topic. I mean, the topic is called radians. So you can't do the whole topic and not know what a radian is. Okay, so we find the radian. Convert degrees to radians and radians to degrees. Evaluate sine, cosine, tangent for angles of any size given either in degrees or radians. Evaluate the exact values of sine, cosine, and tangent for theta is equal to 0, pi and 6, pi and 12.3, 2. Don't worry, we're going through all of it. Use the formulae of arc length, L is equal to r theta, and sector area, A is equal to half r squared theta. And then draw the graphs of function, sine of, See this one right here, drawing the graphs? I've never seen that in a past paper. So, I don't know, maybe your year, this year will be the year. You never know. But it's on your syllabus, so you have to learn it, just in case they decide to bring it. Okay. What exactly is a radian? So you know that angles are measured in degrees. From since, I don't know, maybe like primary school, secondary school, but I know that you know angles are measured in degrees. However, there's also another unit to measure angles, and it's called radians. But what exactly is the exact definition of a radian? Well, 1 radian is supposed to be is, right? So I'll change it. Well, let me just write the S. S, okay. So 1 radian is the angle made by an arc of length equal to its radius. So looking at this, because diagrams always help. This is 1 radian, right? So this is my angle. It's not measured in degrees, it's measured in radians. And this angle, they said it's 1 radian. 1 radian is the angle made by an arc of length equal to the radius. This is my arc. If you didn't know, this whole thing here is called a sector, right? You would learn that in maths, or you probably did already. So this right here, this curve, that's called the arc. And this, we know, is called the radius. So you see when this angle is equal to 1 radian, the radius and the arc are the same length. You good so far?
Yes, miss.
You want to ask me any questions, right? You need to recall that the circumference of a circle is 2 pi r. If I ask you in math, or, well, yeah, maths, to find the circumference of a circle, you know this formula, 2 pi r. So here's how we're going to use this formula to do what we need to do, right? So here I have, we can say that the number of arcs of length r in a whole circle is 2 pi r, which is 2 pi arcs of length r. So, you know, not everybody, including myself, would just pick up that by, seeing words alone. I like to see diagrams. So what exactly do I mean by that? Hold on, let me just. Say I have a circle. Nice big circle. This doesn't look like a circle, but let's just pretend it's a circle, right? And I say this is my sector. It's a radius. Hold on. I need to draw this a better thing. Radius. You know that's a radius. Another radius, right? And you see this radius, and this arc. Remember, the curved part is called the arc. That makes up a sector. So let me just highlight the sector to show you what it looks like. So you see this in yellow, this is my sector. This is my sector. So assuming that this angle here is good afternoon. So assuming that this angle here is 1 radian. So 1 rad. We said, so let me just name this. This is my radius, so I'll name it R. And we said when this angle here is 1 radian, then the radius and the arc are the same length. What does that mean? The arc is the same length as the radius. So I can also put this arc is equal to R. But that's not what I want to know. I said that the circumference of a circle is given by the equation 2 pi r. So what I was trying to find out is how many of these angles here, well, how many of this angle they're in 360 degrees, right? So 1 rad is equal to length r. Should I give you that now? Okay. So if this 1 rad is equal to length r, what that whole, that little part I was reading just now, it says that this circumference, this whole thing, is made up of 2 pi of this question. Okay. So what I was saying was this whole circle here, how many times can I fit this length r in a whole circle? That's what I was trying to do in that note, right? How many times can I fit r? How many times can I get r, a length r, in a whole circle? And we said it's 2 pi. I can get this r 2 pi times. But how exactly did they get that? Well, if we know that the circumference of a circle is given by 2 pi r, and we want to know how many times can I get an arc of length r in the whole circumference, then this is what they did. They said, okay, this is my circumference, 2 pi r, and I want to know how many times can I get this into this. Divide. They would cancel, and that's how you get 2 pi arcs of length r. Everybody good so far? Yes, no?
Yes, ma'am.
Tell me if you're not good, I will explain it again.
Yes, Krish, can you explain it one more time, please?
Oh, you wouldn't say it, so you don't know what we're talking about. Okay, let me just go back for 2 seconds. So people who are late, this is what we're doing. Hold on. Trigs, radians, arc sectors, yeah. Right now we're doing radians, right? Objectives, yeah. We said that angles are measured in degrees. You know that, right? You know that unit, degrees. If I see an angle, it's measured in degrees. However, there's another unit called radians. So what does that mean? Angles are not only measured in degrees, they can also be measured in radians. But what exactly is a radian? Well, 1 radian is the angle made by an arc of length equal to the radius. That's why I have this diagram here. If I'm told that this angle here is 1 radian, then you see this radius, the length of the radius and the arc are the same. That's why they have radius, radius. They're the same length, right? When this angle is equal to 1 radian. You following so far? Right?
Yes, Reese.
Oh gosh, that if you don't know what just happened, let me know. Okay. Please let me know if you don't understand. I can explain it another. Okay. Recall, I was saying that the circumference of a circle is given by 2 pi r. You should know this from maths, right? Lower level maths. Circumference of a circle, 2 pi r. Circumference, also known as the perimeter. Okay. That's what I was saying. We can say that the number of arcs of length r in a whole circle is given by this. But you know, some people don't just, hold on. Okay, sorry about that. What I was saying is that some people, including myself, if I just give you those words there, you know, we can say there are 2 pi arcs of length r in a circle. By just reading that, you might not understand what that just said. And that's why I was explaining. Say I have a circle. Hold on. I have a circle. So a nice big circle. This in yellow is my sector. We know that this is what a sector looks like, right? This is a radius. So this is the center of my circle. This is a radius. So this is not supposed to look straight, right? It's like the two, because it's an arc. And that's my arc. I was saying that if this angle here, so it's not measured in degrees, it's measured in radians. If this angle, they told me that it's 1 radian, so 1 rad, that's how you represent radians, right? So you could say 1 rad or 1 and a little c on top. The c means circular measure, but you don't need to know that. You could just know when dealing with radians, you can represent it like this, 1 rad or 1 with a little c on top. Like the c is the index or the power, whatever you want to call it. Right. So I'm saying if this angle is 1 radian, by definition, why is it? Oh my. Anyways, by definition, this is my radius, and the arc length is equal to the radius. So if my radius, the length of the radius, is represented by, let me say r centimeters, then the length of this arc is also r centimeters by definition, right? Because it said, if my angle is 1 radian, then the radius and the arc length are the same. Okay. What I was trying to explain is that how do we know how many arcs of length r can I get in an entire circle? So there's whole circumference here. The line is going underneath, right? But anyways, the whole circumference. How many arcs of length r can I get in this whole circle? Let me use purple. How many of these? Okay. How many of these arcs can you get in this whole circle? We know that the circumference is given by 2 pi r. We know that formula from lower level maths. So how do we find out how many times I can get this length in the whole circumference? Well, that's what I said. You would say 2 pi r divided by r. Why? How many times can I get this into this? Cancel the r's. So you end up with 2 pi arcs of length r. You understand now, Troy? If not, please let me know. I'll try to explain it a different way.
Yes, Reese, I understand now.
Anybody does not understand? Okay. Please, this is not school where the teacher will just, move on and you don't know what's going on. If you need me to explain again, I would explain. We just found out that there are 2 pi arcs of length r in a complete circle. But that's not what I want to find out, right? I want to know how many radians are there in a complete circle. So let's go back to the board. This is 1 rad, right? This is r and this is r. So we just put 1 rad. We said 1 rad, so just to be C because it takes kind of long to write a rad. 1 rad is equal to a length of r, right? Arc of length r. We said that, how to explain this? I'm trying to explain it in a way that wouldn't mess you up because I know tricks. This is a bit difficult. Some people. Let me erase it. Just bear with me for a second. I don't want anybody to get confused. Okay. Back on track. This is my circle. This is 1 radian. 1 rad. We know that if it's 1 rad, 1 radian, then the arc length is r. So let me put r centimeter. R cm. What does that mean? It means that 1 arc of length r cm. So remember, when this angle is 1 radian, then the arc length is r cm, right? R being the radius. So whatever the radius is, if it's 5 centimeters, that means my arc length is also 5 centimeters. So 1 arc of length r centimeters is equal to 1 radian. So if I said in a complete circle, I have a complete circle is 360 degrees, right? If in a complete circle, a full circle, we just found out that we have 2 pi arcs of length RCM. We want to find out how many radians is this equal to. But how do we go about doing that? Anybody has any idea what this answer would be? How many radians? This is my circle. Circumference. We said this whole circumference would be made up of 2 pi arcs of length r. What does that mean? You see this length r, I could fit it 2 pi times in a full circle. A full circle is 360 degrees. If 1 arc of length r centimeters is 1 radian, how many radians would 2 pi arcs of length r centimeters be equal to? Any idea? Going once, going twice. Okay. Well, when learning math, it's always good to, make real life applications. So if I said an apple, one apple, is equal to $2. And I want to find out the cost of 4 apples. Can anybody tell me what would be the cost of 4 apples?
$8.
8. And how did you get 8?
2 times 4.
Times 4. 2 multiplied by 4. But if 1 apple is $2, then 4 apples is $2 times 4. So if 1 arc of length r centimeters is 1 radian, how many radians would 2 pi arcs of length r centimeters be equal to? Anybody? I need to hold on my chat. Okay, sorry, I didn't see. Yeah, right. Okay, well, since nobody knows, just like I did here, if 1 apple is $2, 4 apples is 2 times 4, which is $8. 1 arc of length r centimeters, if it's 1 radian, then 2 pi arcs of length r centimeters would be, hold on, would be 1 rad multiplied by 2 pi.
Would that be 2?
Continue. 2 pi radian. 2 pi radians. And that's what it was saying here. So a full circle, 360 degrees. But remember, this whole topic is about radians. We're not dealing with degrees, right? We're talking about radians. So what that whole thing was to do was to find out if I have 360 degrees, what is the equivalent of that in radians? 360 degrees is equal to how many radians? That's how we just found out this whole thing. 360 degrees is equal to 2 pi radians. Hold on, and that's what I have here. 2 pi radians is equal to 360 degrees. So if you ever see 360 degrees, you know it's equal to 2 pi radians, right? You're also required to know how to convert from radians, well, from degrees to radians and vice versa. How exactly do you do that? Well, if you're going from radians to degrees, you multiply by 180 degrees on pi. From degrees to radians, you multiply by pi on 180. But you know, it doesn't make sense to me to just give you something and you learn it off. You need to understand why. Why is that? So if we just found out, right, that 2 pi radians is equal to 360 degrees. Okay, before I do that, if I have 2x is equal to, actually, we shouldn't do dollars here. If I have 2x is equal to 6, can anybody tell me the value of x? Ignoring this in the meantime. Just tell me, what's the value of x here?
3.
And how did you get that?
6 divided by 2.
6 divided by 2. Hold on, people join in. X is equal to 6 divided by 2, which is 3, right? Simple thing. So now that I know that x is equal to 3, if I ask you to find the value of 3x, what would be the answer? 3x is equal to what?
9. Wait.
9.
Yeah.
And how did you get 9?
3 times 3.
Okay, 3 times 3. Okay, so we said 2x is equal to 6, therefore x has to be equal to 3, right? Because I said 6 divided by 2. But then if I come and ask you, okay, if x is equal to 3, find me the value of 3x. You said it's equal to 9. Why? Because we multiplied 3 by 3, right? Same concept applies here. Don't want anybody to get confused. You know, the same thing we were doing here is what we're going to do over here now. If I said that 2 pi radians is equal to 360 degrees, how much would 1 radian be equal to?
180.
How did you get that?
Wait, is it right?
Yeah,
You just divide it by 2. 360 from 360.
of course, wait, hold on. Rewind. Okay. Your answer is 180.
180.
Alone, 1 radian is equal to 180.
180 degrees.
180 degrees. Anybody has a different answer? What is 1 radian equal to? Remember, following the same thing, right? 2x is equal to 6, so x is equal to 3. Why? We divide 6 by 2. 2 pi radian is equal to 360 degrees. So what is the value of 1 radian?
180 over pi.
Exactly, 180 over pi. Good job. How did we get that? Just like we said, if 2x is equal to 6, x is equal to 6 divided by 2, which is 3. 2 pi radian is equal to 360 degrees. Therefore, 1 radian has to be equal to 360 divided by 2 pi. Not just 2 pi. Okay, let me erase that. Right. I think it was Kristen that answered me just now. Which reduced to 180 on pi. That's why we say, let me just erase that little. That's why we say, if I want to convert from radians to degrees, this is what I multiply by. Okay. Just like here, right? We found out that x is equal to 3. And when I asked you to find 3x, you told me it was 9. Why? Because you said 3 times 3. So if I ask you, okay, I know that 1 radian is equal to 180 on pi. Find, so let me not use 2 again. Find 3 radians. What would you tell me the answer is? Same concept we applied here applies here. If 1 radian is 180 on pi, how much is 3 radians? Anybody?
Miss, that would be 180 over pi times 3.
Yep, exactly. Good job. I don't know who answered me, but yeah, good job. I multiplied by 3. But of course, we will leave it like that. So that's what 300 degrees. So 3 radians is 140 on pi. Well, it wouldn't be 140 on pi. It would actually, find the exact value. So 540 divided by pi. 107. Okay, well, you would. Oh, just a heads up here. So we got 540 on pi, right? But I was telling you for degrees, you have to find the exact value. Well, you have to find the decimal, not the exact. So 540 divided by pi is approximately 171.9. When you do in degrees, you always do it to 1 decimal, right? So always remember that. Therefore, 3 radians is equal to 171.9 degrees. Everybody good so far?
Yes, miss.
That was just me
Yes,
explaining to you.
miss.
Good job. Thanks. That was me explaining to you why we multiply by 180 on pi to get degrees, right? I don't just want to, give you something for you to learn off. You need to understand why you do it. Okay.
Can be 172 as well. 172.
172?
Yeah, should we run off or don't need to?
No, for degrees, you give it to one decimal place.
Or
Yeah, for radians, you give it to 366. Or sometimes you leave it with 5. Yes. So that was me proving to you that to convert radians to degrees, you multiply by 180 on pi. But now let me prove to you when converting degrees to radians, you multiply by pi on 180. If I told you so same thing, right? 2 pi radians. Before I had it reversed. I had 2 pi radians is equal to 360. Now I have 360 is equal to 2 pi radians. If I wanted to find for 1 degree, somebody tell me what's the answer.
Miss, that'd be 2 pi that over 360 degrees.
2 pi on 360, which reduces to, okay, let me not write that down there, which reduces to pi on 180. That is why we multiply. When converting from degrees to radians, we multiply by pi on 180. And if I ask you, what's the value of 90 degrees? What would be the answer? If 1 degree is equal to pi on 180, what is 90 degrees?
Miss, pi over 180 times 90.
Exactly. Good job. Times 90. Pi on 2 radians. So you see for radians, most times you leave it in terms of pi. Well, for now we leave it in terms of pi, right? So your answer, if this was a past paper question or something, 90 degrees is equal to pi on 2 radians. Everybody good so far?
Yes, miss.